Okay guys, so let's look at this example that I found here on inverse proportion. We did the introduction and now we want to look at the application of what we just looked at in our introduction. So the question says y is inversely proportional to x plus 2, everything in brackets squared. So right away from this moment here, all right, if you've been following me nicely, we know that y is inversely proportional by writing this to what? To the square of x plus 2, okay? And then before we even do anything now, what we need to do is to finish this formula here. So we're going to say y is equal to, the moment we do this, if you've been following and if you've watched the previous video, we need to introduce the constant of proportion in place of 1 and then write x plus 2, then everything squared. So this is our formula now for this kind of situation that we've got. Now, as I said, there will be information that will be given for us to find the constant of proportion. I'll be calling it CP. Okay? So now, let's look at the second statement here, which says, when x is equal to 1, y is equal to 2. So the two variables that we are dealing with, we've been given their values. So this is to help us find what value the constant of proportion is. So what we need to do now is to get x and put it into that equation, y and substitute it into that equation. Then try to work our way around that to find the value of k. So doing that, we are going to say 2 is equal to k over, where there is x we are putting 1. So we're going to say 1 plus 2, then squared, all right? So this is going to give us 2 equals to k over 3 squared. We are trying to find the value of k, so we can balance these two sides and then doing the cross multiplication, because we've done this when we were doing algebra. So this means that k is going to be equal to 2 times 3 squared, which is 9. So this is 2 times 9, which now implies that k is equal to 18. So the constant of proportion is going to be k equals to 18. So what we are going to do now is to say y would be equal to 18 over x plus 2, then everything squared. So this is the formula for y in terms of x. So the question says find y in terms of x. So this is the answer. There are other examples coming where we would move a step further to find the value of y when the x is given in some other statements, but this is it. The most important thing is noticing how to make the formula. So let's look at the second example and see how that is going to differ from this example. All right, so let's just look at that. Okay, so there's this example now which says p is inversely proportional. So it's these statements that we need to be picking nicely. Inversely proportional, because they would affect our formula. There's direct and there's also inverse. So when it's inverse, we know that p, all right, would be, before you even finish the question, would be inversely proportional. So the inverse proportion is always 1 over whatever other condition they are putting. So here they are saying p is inversely proportional to the square of q plus 4. So q plus 4, but they are saying to the square, so we need to square this q plus 4. So before we even go anywhere, we need to now say, okay, fine, we need to change this proportion sign to equal sign. So the moment we do this, I'll keep on saying this, we replace the 1 with k. So we're going to say this is now going to be equal to k over q plus 4, everything squared. So this is now the formula, and this is the constant of proportion, which I'm calling CP. So before, these questions are very nice. Before you even do anything, you should know that what will come next is a statement that will make us find the value of the constant of proportion. So let's look at this question. They are now saying P is equal to 2 when Q is equal to 2. So what this statement is, it should not confuse you. They are giving you these values so that we can find the value of K. So right now we need to replace where there is P we put 2, where there is Q we put 2. So let's just go and do that. So this formula would now be 2 equals to K over 2 plus 4, all right, then squared. So this will now give us 2 equals to K over 6 squared. 6 times 6 is 36, and 36, okay, so let's just go there. So we're going to say if we cross multiply here, we're going to have K equals to 2 times 6 squared, which is 36, and 36 times 2 should be 72. So it means K would be equal to 72. So the constant of proportion is now going to be equal to K equals to 72. So we are going to say now our formula becomes P. So now this is the formula to use for whatever other thing will be following. Be equal to 72 over Q plus 4, all right, squared. So this is now our fully fledged formula. Okay, so we've got our marks there. So let's see now what they are saying. They are saying find the value of P when Q is equal to negative 2. So we need to find the value of P when Q is equal to negative 2. So what we do now is to substitute where there is Q, we put negative 2 in this new formula here. So we are going to say P would be equal to 72 over negative 2 plus 4, everything squared. This will give us 72, all right. You know, negative 2 plus 4 is the same as 4 take away 2, which is 2. So we are having 2 to the power of 2, which now gives us what? 2 to the power of 2 gives us 4. So this implies we've got 72, all right, 72 divided by 4. So then this implies that P would now give us this value here, which is 18. So this implies that when Q is negative 2, P would be 18. So this is the solution to this. So guys, I'm still doing 2 or 3 more examples on inverse proportion, but please subscribe to my YouTube channel. If you are a Facebook fan, you can like my Facebook page and send me the request to your questions. I appreciate those times, guys. If you are a teacher, recommend this page to your students or your children, and other people may be interested in doing math with Mr. Nkata. It's free education, no cost, no what and what. And thank you very much, and let's see the next example.